Did they give you those exercises in class?
Yeah.
So you want me to do your homework for you?
No.
What?
It was like test.
It was like a test.
Yeah.
Okay.
It was hard.
Do you practice though?
I do, and it's just not. It's just not.
It's not methy.
Mm.
Travis, young man, you're gonna have serious problems. Okay, so, but we talked about difference of two squares last week.
Yeah.
We did.
Yeah.
We talked about factorizing. We talked about FOIL, and we've got videos on YouTube. And you promised me you'll watch YouTube. So you don't want to get my viewers up on YouTube. Hey, this man. Eh? Why are you doing this to us, man? Why are you doing this to us? Hmm? Why, my guy? Why? Hmm? Alright, cool. So take out the highest common factors in the expression. Let's look at the concept of highest common factor. Ne? Do you mind reading for us this part here? And we'll go through each of the paragraphs and I'll explain as we carry on. Yeah?
In order to factorize algebraic expressions, we first need to identify common factors.
Okay.
We can write the expression as a product by taking out the common factor. Alright,
cool. Remember, the product is the answer you get when you multiply two things together, right? The quotient is the answer you get when you divide something with another number. A sum is the answer you get when you add different numbers together, and the difference is the answer you get when you subtract something from the other. So it's important to know those because, like I said, the answer is in the English that is used in the textbook. The answer is in the English. So let's start. This is the way it starts. Ne? Sum, answer from adding, difference, answer from subtracting, product, answer from multiplying, and lastly quotient from dividing. Ne? So I'll put a big exclamation mark next to it. Ne? The reason for that is so that you notice it. You note it always. Ne? It's very important. Ne? So there it says we will take out a factor from an expression and write the answer as a product of this and that. Right? That's important. Product of this and that. Ne? So now read the next part.
To check factorization, multiply out the brackets. The answer must be the original expression.
Okay. So what are they saying in those two paragraphs? The first thing that they're saying is that if you have an expression like 2y squared plus plus y, ne? If we take out a factor, common factor from this expression, if we take out a common factor from this expression, the common factor is gonna be y. So if we take out y, so let's say y, and we take it out of the brackets. When we take out y, from these brackets, we will be left with 2y plus 1. Ne? And now the second paragraph says to check the factorization if it's correct, we need to multiply out the brackets again. So what we've done is we've gone to the step of taking out a factor. To check, we have to go a step back, which is going to take us back to where we come from. And here's what happens when we do that. For example, if we take this y and we multiply it by 2y, we will get 2y squared. Ne? And if we take that y again and we multiply it by the number 1, we will get plus y. You follow? You follow?
Yeah.
Are you sure?
Not really.
Not really. Okay, why are you not sure?
And then the 2.
And then the 2. That's a good question. That's a very good question. Kopan, would you like to answer that?
This one.
Yeah, no, not the exponent. Not the exponent. This 2 here. Why do we leave it in the bracket? What do you want to understand, Travis? Why do we leave it in the bracket? Why do we not take it out of the bracket? When I multiply out. That's good, because it's not a factor that we can take out. If we had a 2 somewhere here, maybe we'd take it out. Let me make an example. Let's say we have let's say we have 4y squared plus 2y. Nah? Let's say we have 4y squared plus 2y. If we take out a factor of 2y, then we will have 2y into 2y plus a 1. Right? Now when we do that same multiplication thing, we would have 4y squared, and when we multiply again there, we would have 2y.
4. Oh, because 2 and 2.
So does it answer?
Yeah.
Does it make it clear the previous example?
Yes.
Why we didn't take it out?
Yeah.
Here we can take it out because indeed the 2 and times the y, the 2 times the y are a factor in both expressions of y squared and y. Does it make it clear?
Yeah.
Okay. Now, does it start to make sense how you can think about these that you have to answer in the test, or not still?
Kind of, Mike.
Kind of. Okay.
And
We're gonna get to those. So now let's carry on, because I was just explaining these paragraphs that you had to read. Now the next paragraph, what does it say?
A switch around is when the order of subtraction is changed.
A switch around is when the order of subtraction is changed. Okay. How do I explain? Let's do a switch around. So a switch around, we want to change the order of subtraction. And how we're going to do that? Let's say we have let's say we have 4y squared minus 2y, ne? We're gonna do a switch around, ne? So if we do a switch around here, we can take out 2y, or let's take out negative 2y, ne? Then this would be 1 minus 2y. Do you see what happened?
Sorry.
Switch around. We just did a switch around. Ne? We just did a switch around.
Okay.
Can you see how?
Yeah.
Because we took out negative 2y. So when we take out negative 2y, we have to multiply it by 1 to get negative 2y. So because we took out negative 2y, it switches this one and it brings it to the front. And then it switches that one to a negative. But when we do that multiplying out, so we wrote this as a product, like it was said in the first paragraph. This is the product. So when we do the multiply there and multiply there, then what happens is we get negative 2y plus 4y squared, which then equals 4y squared minus 2y. That's your switch around. You follow? Yeah. So it's a trick that you can use when you're factorizing, and you need to be very keen, like pay attention to detail. It must be, there is a word in English, it's a very difficult word, barke meticulous. It means to be, you know it. Yeah, it means to be detail oriented. You must pay attention to detail. No detail skips you. You're sweeping the floor, you see that granule that you swept over. You get it? You're washing the dishes, you see that corner of grease on the plate. That's meticulous. So you need to have the same type of eye for these kinds of things. Like, where can I switch around things? We get it. Alright, then the next part.
For example, bracket B minus A bracket is the same as minus bracket A minus B bracket.
You see, which is exactly what we just done. Yeah. Okay, carry on.
Well, watch out for switch arounds when looking for common factors.
Yeah. So what they're saying is sometimes an expression or a number of expressions in, an algebraic problem would have switch arounds. You see why I say attention to detail? They're saying exactly what I've just said, but they just wrote it however they published it in the book. But the goal is, be careful of things that might not look like they're factors, because they might be. You just need to switch around by taking out a negative sign. Or a factor as a negative factor. And that way you will see where the factors come from. Yeah, everyone? So again, exclamation mark. Okay? Again, it's got exclamation mark. So this is your switch around, right? All right. And then what do they say next?
3a bracket x minus 2 bracket plus 4b bracket 2 minus x bracket has a common factor of bracket x minus 2, but the bracket must first be
switched around. So what that means is we will say 3a into x minus 2 minus 4b into x minus 2. And then this will be 3a minus 4b x minus 2.
Yeah.
You get it?
Yeah.
If you don't get it, forget about it. You get it? Now what? So that's the switch around. And this is the nice thing about maths that a lot of people skip. And I think maybe a lot of the times it's not taught well. It's not delivered well. Right? It's that there are so many tricks that you can use to manipulate the situation, which is an algebraic expression or equation, to your advantage. And each of these tricks, they are allowed as long as you follow the rules of what we do in maths that have been established and have been proven to work. Alright, so switch around is one such trick. Switch around is one such trick. It allows you, 2 minus x does not really look like it's a factor as x minus 2, but it's actually the closest to a factor in that expression that you can think of. So you just need to be smart enough, meticulous enough, detail-oriented enough to see that if I take a negative sign out of that, then I switch around the terms. Because the negative sign has the power to change the sign of other numbers' signs. Alright? Positive does not change anything, but negative can change positive into negative, and negative can change negative into positive. Alright? Yeah, so that's what that means. Ne? And then just read for us this note there.
Note y minus x equals minus bracket x minus y bracket, but y plus x equals x plus y.
All right, so this is an important differentiation. This is an important exception. Exception, Gore. However, in this case, this switch around does not apply. Remember, it is negative sign that can change the sign of other signs of other numbers, ne? But positive does not. That means y plus x equals x plus y. Now what? But switch around is nice because it allows us to achieve this kind of expression when we have a negative sign in between terms. Switch around allows us to do that when we have negative sign between the terms. But it also means that if you take out that common factor of -1, you're going to change whatever is outside the bracket. Because remember, you are writing this as a product. Now, yeah, but okay, then we will do an example. Let's do examples. We'll do one example, and then we'll do the 2 problems that you said you were struggling with. It's only 2, ne? All right, cool. Because I can sense you want to do those so that you can feel some sense of safety with regard to your test. And that's the whole point. But again, you need to practice often so that you build the confidence to not need that security from your tutor. I understand where that comes from. You want to feel safe, and that's okay. But you must also, you're not going to stay close to your mom forever. No one does. Yeah. I know, like, some of us are old and we live with our mothers, but it's not forever. It's for a short term, we're fixing this and that. And it's the same with everyone. Yeah? So you're not always going to feel safe. There's a saying that a ship that is always at the harbor is not really working as a ship. Ships are not meant to be at harbor. They're meant to go far in the sea. Planes are not meant to be at the airport. They're meant to be in the air, fly to the next destination. See? Yeah. So think of yourself like that as well. Think of your math like that as well. Don't break your pen and these things now.
I can't even.
Yeah, you found it. Okay. Yeah. So you have long nails, so you're playing with things and you are. All right. So let's do examples. All right. So example: take out the highest common factor in the expressions below. Right. So let's start with 3abc plus 12ab. Let's make next slide there. Minus 6ac
minus
9 AD. Right, so highest common factor. When we look at 3ABC, 12AB, 6AC, and 9AD, which factors would you say are common? Let's just talk about that. We can also look at the answer that they suggest here and ask yourself why they suggest that it's the common fact, right? Kapan, you can get closer so you can see. You could get closer so that Kapan can. Yeah, so this is the answer that they gave here, and then they show how they took out the factor, right?
3 is the highest.
It's the highest common factor. Why do you think that is? If you had to think about it, why would you say the reason is for that? Remember, we wrote this as a product. Product is the answer you get when you multiply things, again. So when you think about it, we're going to have to multiply 3A with BC. And that'll give us 3ABC. You see, if we do the same for 3A and 4B, 3 times 4 will give us 12. And then A times B will give us AB. And 3, then that will be 12AB. We do the same to way over there. It's going to be 3 times 2 is 3 times negative 2 is negative 6. And then we get AC. And then that is going to give us 3 times negative 3 is negative 9. And then AD.
Okay.
You get it?
Yeah.
So that's where that reasoning comes from. Because when we take out the 3A, we are left with BC there. When we take out the 3A, we're left with 4B there. When we take out the 3A, we're left with negative 2C there. And when we take out the 3A, we're left with negative 3D there. Now, but again, you'll only develop a keen eye, a detail-oriented eye, a meticulous eye, the more you practice. The more you practice. Okay? Yeah, you'll only develop that eye the more you practice. Okay? Alright. Let's do the next one. 6x squared y minus 12xy. Highest common factor. What do you think it will be?
12.
Nope, it's not 12. It's not 12. Think about it. Highest common factor. Not the highest number in the expression or terms, but the common factor. Remember, common means, what's common between the three of us here?
Maths.
Okay. And then what else? We've talked about maths, we're discussing maths. Okay, what else? I know I'm older than you. I'm your tutor, your learners. So that doesn't make us common. But the maths makes us common. But what else? We're all male. Is that not so? Or do we have a female in here? Mm-hmm. No. So that's what common means. Yeah? So if we take out maths and masculinity or being male from that equation, that's the common factor. Then what's left is tutor, learner, mid-30s, late teens, early teens. You get it? Yeah. So that's how you think about common factor. So we're taking out maths and being male outside. We're left with different age groups, different roles. You get it? Yeah. So does it make the common factor thing more understandable? So again, common factor.
Y.
X and Y, good. X and Y, good, but that's not all. 6xy, 100%. So now do you get it? Yeah, so 6xy, we take it out. Then what are we left with?
12xy.
Nope, that's not correct. Because if we're left with xy, when we multiply back, we're going to get x squared y squared, which we don't have in the original expression. We do have x squared y, but not x squared y squared. So if we take out 6xy from here, what are we left with?
1.
No. But you'll see why when we get the correct answer. You'll see why. Don't feel discouraged. Accept that you're not correct and be open to learning what's the correct answer. Okay? Don't be discouraged whenever you get an incorrect answer. But be courageous enough to try and think about the correct answer and why it will be correct. Say whatever's on your mind. If it's correct, we'll...
It's not correct though.
Yeah, but say it. Let's hear it.
Minus.
Minus what?
The sign.
The sign?
Minus, yeah.
No. So what happens if we just put x there? What happens if we multiply 6xy by x? What do we get?
6x squared y.
Excellent. It goes back to... So if we multiply out like this, that's what I'm asking. If we multiply out like this, we go back there. If we multiply 6xy by x, we go back to 6x squared y. You check. Now, if we do the same for 12xy, what do we get? If we take out 6xy from negative 12xy, what do we get? What do we multiply 6xy by so that we can get negative 12xy?
2.
Negative 2. So let's check. If we multiply 6xy by negative 2, we will get negative 12xy. So then this becomes the correct answer. Okay. So the correct way to think about these types of problems is, when I take out the factor, what must I multiply the factor by to get the expression that I had before? Is it still far, or is it getting closer?
No,
It's getting closer. Okay. Let's do another example. We've got 15x squared minus 25x plus 5. Now let's take out a common factor, the highest common factor.
X.
We do not have x here, so it can't be correct. What's the number if we don't have x on all of these, ne? Then we are only left with taking out the common factor from the coefficients, these numbers. Can you see that?
5.
5. Good. So if we take out 5 there, then what must we multiply 5 by to get 15x squared? 3. Okay, but that's not everything.
-3.
You know what's funny about how you guess? You would partially guess the correct answer, and then when I say that's not complete, you go in the opposite direction. And it's fine. I mean, it's not correct, but I get. But that's how you seem to think about it. So we're correcting that. So think about it again.
3x.
Okay, but now what about that exponent? You see, so it's 3x squared, because if we multiply the 5 by the 3x squared, we go back to the 15x squared. Okay, so let's do the same type of thinking for negative 25x. If we took out 5 as the common factor, which is the correct highest common factor, then what must we multiply 5 by in order to get negative 25x?
Negative 5x.
100%. So do you see why? Negative 5x. Okay. And if we take out the factor of 5 from positive 5, what must we multiply 5 by to get positive 5? 1. Yeah. Next time, say it out loud. Don't put up your finger. Don't be afraid. Just say it. Ne? If it's not correct, we correct it. If it's correct, we celebrate it. That's just that simple. Ne? The last one, right? We've got 4x into a plus b minus 3y into a plus b. So how do we do this one? It's a bit tricky, ne? It's not like the other three. What's our common factor there? Common factor does not have to be one number. Ne? It can also be two numbers that are unknown in a bracket. And that's what this question is asking.
AB.
AB is the common factor. So if we take out AB, A plus B rather, then what are we left with there?
4x minus 3y.
100%, 4x minus 3y. Because this we can write out as 4x into a plus b, for the simple reason that when we multiply and we use first, outer, inner, last, ne? First and outer is this. This is that. And then again, if we do inner and last, it's this here, which is that. See, so again, look at it and think about it in this context. The whole bracket is the common factor to both terms. You see why I say sometimes the answers are in the English we have to read, and why I say, guys, let's read. Yeah, ask.
On the first equation, what if I say array is common in the other three numbers, because 3 goes here and here and here and it doesn't leave a remainder, and a is common in the other,
In all of them. So yes, you are correct, because but we can't write it like this. We can only write it like that, because you are correct. 3 is common in 12, because we multiply 3 4 times to get 12. 3 is common in negative 6. We multiplied negative 2 times to get negative 6. And again, 3 is common in negative 9, because we multiplied 3 times to get negative 3. So that is a correct observation. Again, all these 4 expressions, they have the unknown number a. So we can also take that out as a common factor. But remember, because they are multiplying, yeah, you must move them together like that. So it's a good observation. It's a good observation. Tarisu, do you have a question? Okay. So let's quickly do the problems that you said you were struggling with so that you can feel safe. And then we'll call it a day. We're a bit over time. Sorry about that. Let me just do this in case I've got learners because our class is overlapping. But I think the other one said they were not well. So which one did you say it is?
2a.
Okay. Let's see.
7x squared y to the power of 3 minus 14xy squared.
And then which one?
3b.
And what is it? It's
3a bracket x minus y bracket plus 2b bracket y minus x bracket.
Y minus x. Okay, cool. So again, these problems, we're going to do them and you're going to see everything that we discussed here. From taking out the factor that's common, which is everything that we've done in these examples, to the switch around, which we talked about. And I can tell you because we have switch around here. Can you see? We have switch around there. Can you see? Because in the first bracket, we've got x minus y, and in the other bracket, we've got y minus x. So we're going to have to do a switch around. Let's see. So, but again, you said you want to feel safe. I'm just going to open the call here just to see who's in class. Okay, it's not to take down. All right, so let's start with the first one. When we take out the common factor here, what's the highest common factor?
xy.
Xy is part of it. So well done for spotting that xy is a common factor, but that's not the highest common factor. Remember, we're looking for the highest common factor.
Square. Xy square.
Y squared, yes, but that's not the highest common factor still. xy is part of the common factor or the highest common factor, but that's not the highest common factor. Remember, the highest means it's like how do I put it? How do I explain it? Highest common factor. Okay, when you're listening to a music album and you're selecting your favorite song, the favorite song has to be on several levels. It has to perform according to whatever metric you're using. It has to perform, and this is for your favorite tracks, right? It has to perform on certain metrics that you regard. These are metrics for my favorite type of music, and it has to perform at the highest scores on each of those metrics, right? When an Olympic sports player is scored and judged on several things, they have to perform the highest on each of those metrics that they judged on, right? So think about a highest common factor like that. What's the highest quality factor that you can take out there? That is the highest common factor. So xy or xy squared, yes, they are part of the factor. That's not the highest common factor.
Is it the number also?
The number is also included, yes, 14. As a hint. Okay. Now, we don't have to think about it in terms of the largest number. And the reason I say that is because if we take out 14, how do we take out 14 from 7? We're not going to be able to work it out. So that's why I say we don't have to think of the largest number. yes, highest common factor does mean the highest number, not the highest number, but it means the highest number that's going to be divided into, so that when you multiply, you get back to 14. So when you take out a highest common factor, what is it that we multiply the factor by so that we get back to 7? And what is it that we multiply the factor by so that we get back to 14? That's how you think about it. Not the highest number in the expression is 14, therefore I take that out. Because how are you going to take that out of 7? It's going to be a challenge. Like, my English is probably not so great to explain this, and that's my limitation. But what I'm trying to convey is, when you think about taking a highest common factor, it needs to be common to both 7 and 14. 14 is not common to 7. But think about this. Is 7 common to 7 and 14? It is. Why do you say that?
Because 7 goes into 7 once and 7 goes into 14 two times.
You get it now? Yeah, so the highest common factor doesn't mean the highest number of these two. But it means the number that will divide into the smallest and the highest is going to be the one outside of the bracket. That's what highest common factor means. It doesn't mean the largest of the numbers. No, that's not correct. The correct one is, I'm going to take out the highest factor. When I take it out, I need to get back to 7 and I need to get back to 14 when I multiply back. Yeah, so that's where we're taking the thinking. Yeah, so let's think about it again. You had x, you had y, and you also have to have a number. That's my hint. So what would the number be? And what would the highest factor for x be? And what would the highest factor for y be?
7.
So 7, definitely. And then what else? X squared.
Y.
X, okay, x I can agree, but y...
I mean, square, sorry.
Which one is squared, the y or the x? The x?
Yeah.
Again, it goes back to the 7 and the 14. It goes back to the 7 and the 14. The same way we think about the 7 and the 14, not necessarily the one with the highest exponent, not necessarily the largest number, no, but the factor that when we multiply back, we will get that and we will get that. So think about it again. That's why I left the x as it is, and I'm not putting a square. Because I know when I multiply back, I need to get the 7x, the x there. That's why I'm leaving it as this without an exponent. We still have here, we haven't taken out the highest common factor there. So what would the highest common factor for y cubed and y squared be? What would the highest common factor be there? Come on, would you like to take a guess? Y squared. Okay, let's try that. Okay, so we've taken out 7xy squared. Then what must I multiply 7xy squared with so that I can get 7x squared y cubed? When I multiply back into the bracket so that I get this term, what must I multiply this by?
X and y.
Okay. Let's check. If I multiply 7, I'll get the 7xy, I'll get the 7. If I multiply the x and the x, I'll get the squared. And if I multiply the squared and the 1, I'll get the cube. So that does look correct. So I can take that. I can take that. All right. Now, let's go to this term here. Using the same thinking, we've taken out the common factor 7xy squared. What must I multiply 7xy squared with so that I get negative 14xy squared? What must I multiply that with?
Minus 2.
100%. And let's check. If I multiply 7 with negative 2, I get negative 14. If I multiply the x with, well, there's 1 there, so I get the x. And if I multiply the y squared with 1, I get y squared. So big ups to you, man. Well done. Well done. So again, if it's incorrect, we will correct it. And if it's correct, we celebrate it. Right? So that's how we think about these. So what must I multiply this by so that I get back to that? That's all there is to it. Now let's do the second one. All right? And remember, this one has got that property of switch around. Remember how we do switch around? Whatever's inside the bracket, we take out negative and it multiplies this that is just next to the bracket so that we can swap the order around there. All right? So let's think about that. How do we do? Let's start with that switch around first. So we'll have 3a into x minus y. And then if we take out the negative there, so let's do the switch around. You guys tell me, what do I do next? You guys tell me, what do I do next? Remember, switch around is if I have a minus b is the same as negative into b minus a. That's switch around. Yeah? So the same thinking we apply there.
Plus.
There's not going to be a plus there.
Minus.
Okay, where do I put the minus? Like after this bracket?
Yeah.
Okay, so minus, and then what do I write next?
2b.
Okay, 2b.
Bracket.
All right.
Y minus x. Bracket.
No. I'm not going to do that because I've already taken out the negative, so the order of these two needs to change. Remember, the negative sign changes the signs of the other numbers. So if I'm taking out the negative and I'm putting it there, then it means the order there must change.
Into plus.
Plus what?
No, the symbol.
The symbol is plus. No. The sign between the two still remains negative.
X minus y.
Yes. X minus y. Switch around. Mr. Wordsmith, rapper. Switch around. Yeah?
Okay.
Do you see this here? This here. We take out the negative sign from here. And what it does is it switches around the order of those two. It doesn't change the sign between them. It just switches the order around the two.
But it's the same though.
No, it's not the same. Because if I multiply this negative by the b, I get negative b. If I multiply the negative by negative a, I get the positive a.
Oh.
So it's not the same.
Now I get it.
It's not the same. It's not the same. You get it. If you don't get it, forget about it. Mr. P is very patient with you. Eh? Do you not see that? Because we have talked about switch around 4 times in this class in the last hour. 4 times. Yeah? So be patient with yourself. But then again, and I always say, if you feel maths is not for you, I'm not going to force you to do maths. But if you feel maths is not for you, you will know. But this is what it takes to do maths. Just this kind of thinking. Né? Yes. So if you want to be good at maths, you need to be open to thinking about problems like this in this manner. Né? Pay attention to detail. Be keen. And don't just take things at face value. Investigate even your answers and be like, no. Haven't you noticed, when I'm not sure, I'm like, wait, but here, God, I'm not doing right. Because there's ways to do things, and you always have to interrogate your way of doing things against what's the norm. Yeah. Because when you go outside the norm, teacher will be like, no. Professor in the university, no. So that's how we do it. Anyway, let's finish with this problem so that I can release you guys. It's getting late. Now, what's the next thing we do?
Brackets.
Okay. What's the common factor? Remember the last problem we did when we were doing the examples?
XY.
XY is a common factor. Very good. X minus Y is a common factor. X minus Y is a common factor. And then what else?
Minus.
Okay, remember this problem here. Let's go back to the previous slide. Remember this problem here? This one here. We took out the common factor of A plus B. And what did we do with these two terms here? Kopan, are you tired? I know we are tired. I've had a long day, guys. I was making sandwiches in a school, peeling potatoes, cutting up bread, filling them with food. I'm very tired as well. But this is not we've just done this now. It's this example, this one. It's just it has switch around, and we've just done the switch around. So now we're left with these two. What do we do with them?
3a minus 2b.
3a minus 2b. Excellent. Oh, sorry. Next slide. Yeah. 3a minus 2b. You get it? You don't get forget about it. Yeah. It's exactly the same problem. It's just it has a switch around before we get to that step. So again, tell you the same problem that you were worried you are not feeling safe about. There's the equivalent. Just that it has a switch around and the theory of switch around is there. It's not the same thing. There's switch around in your book and you do that step before you get to this step. But here is the English there. There's the English. It's exactly the English you need to solve that problem. And then the switch around you also do there, just so you can have those two to look alike. Alright. So again, and I'm gonna ask you, I know you behave in a way that I always call out. I'm not gonna call it out on but I ask you nicely, please practice these problems, even the ones with the answers given to you. Practice them and ask yourself, what happened? Because practice makes perfect. Yeah. How else are you good at writing the lyrical content that you shared with me the other day? Do you not practice that?
Yeah.
Yeah, so same thing. Kopan, do you play sports? What do you do outside of school?
I rap like you.
You rap?
I like
Yeah.
hip-hop music.
You write hip-hop music. I want a little comp. You guys don't look up. But you do nyan. It's fine, but my point is, in order for you to write, like the next time you write and then it impresses you and you want to share it, how many times do you do that until you feel so confident that, this one I get number? You practice. Same with math. And sometimes you just have to do the ones that already have answers so that you can understand what the thought process is in the learning material that you have. So again, guys, practice. Ne? Don't just practice because you're with Mr. P. Yes, you have to spend time with Mr. P, but practice also on your own. Ne? Yeah. Thanks for coming. If you don't have any questions, you're ready to leave. Finally.